Hi and welcome everyone. In today's video we won't focus on Arduino, but build a very important tool for everybody who has something to do with electronics. Let's get right into it. As you may have guessed, we will build a variable lab bench power supply. First we have a look at the components, and there are quite a few of them. The main component is this notebook power supply, which can output up to 15 volts and 8 amps. This is more than enough. This power supply will be plugged into a circuit where a DC to DC converter will do the rest. This one takes 8 to 40 volts as input and has an output efficiency of 95%. It has two potentiometers to regulate the current and voltage, but they are not handy at all, so I will use two external ones that I will solder instead. By the way, this one has more than one rotation and I will use it to adjust the voltage precisely. For adjusting the current, I took a simple potentiometer, because there I don't have to be that precise, but it's up to you which component you choose. Next we have a current and voltage display, which can measure up to 10 amps by 200 volts. For my personal use it is more than enough. I have chosen banana connectors and a corresponding jack for them to make connection of different consumer devices easier. I also included some USB ports to take 5 volts if necessary. I made the case out of 8mm thick plywood, but as I own a 3D printer I could not refuse using it in this project, so I printed two parts to mount the top plate and big front part with all the holes. Okay, now we went through all the components, let's do some work. First I made the case. I cut the plywood with my circular saw and used the jigsaw at some point as well. My circular saw has a vacuum cleaner inside, which makes it very noisy. Listen. The funny thing is that the motor of the saw has 1 kilowatts of power and the vacuum cleaner 1.1 kilowatts. 3D printing took around 1.5 hours and most of the holes were perfect, except for two for the banana connectors, so I had to drill a little bit. Now I already fixed the design, so you should not have any problems assembling this project. The next step is to glue the case together. While it is drying, we will have a look at the circuit. So we get a 15 volt input from the notebook power supply. I added a switch to turn it on and off. If the switch is closed, the USB hub gets powered. We don't need to step down the voltage because on the USB module there is already a converter. I also included a fuse for more safety. The display, which also measures the voltage and current, gets powered as well. Next, the voltage is stepped down by the DC-DC converter, while we adjust the output voltage by rotating one of the potentiometers. The other potentiometer is used for adjusting the current. Now it is very important that the minus terminal goes through the volt-ampere meter to the banana connectors. Like this we can measure the current. The positive terminal is connected to the banana plus terminal, but there is also a wire from the display connected in parallel, which allows to measure voltage. And that's it for the circuit. Quite easy, right? The case just dried and I sanded it in my school to make it look nicer. It's time to solder everything together. Make sure you use shrinking tube to prevent any short circuits. If you don't have any shrinking tube, there is a link in the description where you can buy it for cheap. I recommend using thick wires for the power for more safety. Now, when the circuit is complete, we can close the top cover. There we will need M3 nuts. The front panel is also mounted with screws. Okay, it's time for a test. First I connected a motor and it worked well. As you can see, the voltage regulation works fine. The USB hub provides power as well, so an Arduino can be powered. But what if we want to regulate the current? To do so, we need to show both contacts and then, using the potentiometer, adjust the current. This can be very useful when powering LEDs. And with this bright shine, I would like to end this video. I hope you liked it, and if you did, you know what to do. I will publish a step-by-step instruction on my website, as well as the parts list for this project. Check out the description for more information. Thank you very much for your attention.